Welcome to the 121st video on misconceptions in physics. My name is Ratankar Rao. I teach physics in an international school in Bangalore, and my hobby is to do these videos. Misconceptions is nothing but concepts which are being understood incorrectly or not being applied appropriately to the given circumstances or the context. Okay, so with this, we have totally finished so far around 120 videos. Now today's video is 121st one. And if you want to get a recording of all these videos, it's completely free. You'll be able to view this, okay, in my website from here. Or maybe if you want to know each and every, if you want to see this with notifications, you can view it if you become a member or if you become a subscriber for my channel. Definitely you'll be able to get the notifications. Okay, with this short introduction, let me proceed with the new problem. So currently we are solving problems related to logical reasoning errors, which means, okay, so things which are seen to be obvious are not obvious, but we reason it thinking that, okay, hey, this is what it is. And I think the answer should be something like this. Okay, so we make mistakes based on this. And this is what is a set of problems shown here. Okay, so now let us start with this. Now, a train is moving along a straight line with a constant angle and constant acceleration alpha. Okay, so you have a train. I need some space. What I'll do is I'll write it here. Train which is moving with an acceleration alpha. Acceleration alpha. Usually we give it as A, but here it's given as alpha. This is not my problem, taken from JEE advanced paper. A boy standing in the train throws a ball forwards with a speed of 10 meters per second at an angle of 60 degrees to the horizontal. Now, inside the train, there's a boy who throws a ball. Now, as a result of it, what will happen? The ball, when you are standing here and you are throwing at an angle of 60 degrees to the horizontal. This is the 60 angle here. So now this will go like this and fall here. It will fall here. Okay. The boy has to move forward by 1.15 meters inside the train to catch the ball again. So he has to move 1.15 meters. That's what, okay, is being thought of. Okay, so then he moves it to once again catch this 1.15 meters. And then to catch it back at the initial height, what is the acceleration of train meter per second? Seems to be very, very simple question. Arey yaar, what is so special? Now, what he has done is, my student had done is, like he took the initial velocity to be u equal to 10 meters per second, which is nothing but the velocity which you throw here. And this makes an angle of 60 degrees. So since we are going to find out what is the acceleration of the train, there's no need to calculate the y value because it's only about the x-axis, right? Because train is moving along the x-axis. It's not going up and down, right? So therefore, we just need to find out this. And we have taken ux equal to 10 cos 60, the component of this u along this direction, okay, which is 10 cos 60, 10 cos 60, which he substitutes this value and get the answer as 5 meters per second. And then he considers that the ball, once again, when he catches over here, the distance is seen to be 1.15 meters. He writes this value. And then he assumes that Vx equal to 0. I do not know. I asked him, hey, how can you assume Vx equal to 0? When the ball reaches your hand, how can it be? He said, sorry, anyway, I'm going to catch it. When I'm going to catch it, definitely Vx should be 0. That's what he said. I was not very happy. I said, how can this be? You cannot have it something like this. He said, sir, when the ball comes to my hand, is the ball moving? No, right? With respect to the train, the ball is not moving. So therefore, definitely Vx should be 0. Okay, let us see what else he has done. Okay, so this is the biggest misconception he has used. Okay, so usually many students do commit this mistake. When the ball reaches my hand. Now the question is not when the ball reaches the hand. When the ball is 1 nanometer away from your hand. Okay, what is your velocity? You threw it. Okay, the ball will have some velocity. If Vx was 0, the ball would have not come to your hand. It would have dropped somewhere else. Right? Vx equal to 0. So this is incorrect. This is a misconception. And finally, he uses this equation. Vx square equal to ux square plus 2x. V square equal to u square plus 2x along the x-axis. That's why I written x over here. And as a result of it, he finds out what is the acceleration. And he gets the acceleration negative, minus 10.89. What do you mean by negative acceleration? Negative acceleration, deceleration, which means what? The ball is moving faster and the train is going backwards. Yeah, what is this? Very big absurd thing. And finally, what he did was he said, no, sir, I took the magnitude. You should take the magnitude and you should write this 10.89. Okay, totally incorrect. Okay, concept itself goes away. Now, why did he do this? Because he made a mistake here. Okay, so in IBDP, where I teach, we call this as a double dummy error, which means you make a mistake here. The same error is carry forward over here. We also call this ECF. Okay. So now this is what happens. So one should be very carefully analyzing the problem. It is not only the parameters that is being given, take up those parameters, substitute and get the answer. But instead, you should understand what is being given, what is being asked, and what is the procedure over here. That's very important. Now so this is a misconception. This solution is incorrect. Now, why did the student do this? The reason is because he assumed that this is true only when, okay, you have an object of mass m, then you had, let us say, for example, ux, a velocity of 5 meters per second. This is on a floor. Now, when the object is moving and it reaches to a point over here, you just slide it, okay, just throw it away. Okay, the object was moving, and after some time, you see that it slowed down. 5 meters per second become 4 meters, 3 meters, 2 meters, 1 meter, 0 meter per second. When it reached here, it became 0 meter per second. Why did it happen? Because there was a friction here. You're just pushing it on the floor, right? And then you run behind it and say, oh, I have caught it. If the problem was something like that, then definitely this will mean some meaning. And the acceleration that you are calculating, which you calculate as negative, will not be the acceleration of the train. It would be the deceleration of the object that you have pushed. But this guy, he confused just with that. And finally, he reasoned saying that, okay, logically I am true, which is completely wrong. Okay, now let us look at the correct solution. Now, what is the correct solution? Correct solution would be like this. Now, just give me a moment. Someone at the door. Yeah, what has happened to the mouse? Just a minute. Okay, I am back. Someone was at the door. Right. So now what is the correct solution over here? Now, when you threw the ball here, what happened was the ball started moving like this. The train was also moving. Okay. Now, the ball, it took a time of t is equal to 2uy divided by g to reach this point, because it's a horizontal projectile motion. So this had taken 2uy by g. What is 2uy by g? Which should be 2u sine theta divided by g. Those who have worked on projectile motion, you might understand this. Okay, those who are at the verge of 9th and 10th grade, you may not get this because you have not done this one. Okay, so therefore, this should be 2 multiplied by, what is u? U is 10 sine 30, sine 60, sorry, sine 60. Let me take g also 10. So this goes away. So it should be 2 into root 3 by 2, which is equal to root 3 seconds. The time taken by the object, by the ball, to start from here and to reach here, okay, in a moving train is seen to be root 3 seconds. Now, we have got the value of time. Now, what we do is, we have seen to it that the total distance traveled by you. Okay, see, though the ball starts moving over here. Now, as you started moving, you moved a distance of 1.15 meters. You moved by a distance of 1.15 meters, and then you were able to catch the object. Okay, so therefore, see, I hope you understand this. See, it is not something like you threw the ball fell at that point. Okay, so when the ball fell at that point, you were also supposed to move by a farther distance. Why did you move? Because the train was moving and you had to move in the same distance. So 1.5 meters you moved across, plus the train accelerated by an a. So in this given time, the train has moved by a distance half at squared. So this should have been equal to so much. Okay, thus the total displacement is nothing but x is equal to half at squared plus root 3 by 2. Now, how do I find the value of x? That's the next question you should ask. Now, x, what is x here? X is nothing but the range of the particle. Okay, when you threw the ball, you did not accelerate it. Okay, it was an accelerated frame, but when you threw the ball, the acceleration of the train did not affect the ball, right? You threw it, thus you have x is equal to ux into t. What is ux? Ux is nothing but 10 cos 60 multiplied by time. What is time? Root 3. Root 3. So thus you get this as 10 into cos 60 is 5. So this should be 5 root 3 meters. So ball has moved by a distance of 5 root 3 meters. In addition to it, okay, to catch it, you have been moving. You moved by a distance of 1.5 meters, 1.15. Thus now let us substitute this. You get this as 5 root 3 is equal to 1.15 plus half a t square. And what is the t square? T we already calculated. What's the value of t? Root 3, right? So I'll substitute this root 3 the whole square. Thus, now this will be 1.15 plus half a multiplied by 3. Now I need to find out what is this value. 5 root 3 value. Let us find out this so that I will be able to solve the problem. Where is my calculator? Yes, it's here. So I should get the answer. Now 5 into 1.732 is your value for root 3 is equal to 8.66. This value is 8.66. This should now be equal to 1.15 plus 1.58. Right? 3 by 2 is 1.5. Thus now I have 8.66 minus 1.15 is equal to 7.51 divided by 1.5 will be equal to 5. Okay, so this should be, so 8.66 minus 1.5 is equal to 1.5a, or this implies a should be equal to 5 meter per second square. A equal to 5 meter per second square. Okay, so I hope you understood this method of solving this problem. So if you still have any doubts, the first thing is you should know like how to solve the projectile motion problems. Okay, and then this method you can easily get it across. Thank you friends for watching. If you have still any doubts, you can always write back to me. I'd be happy to explain it once again. Okay, so where did you miss it? Because it's a JEE mains, a JEE advanced problems. So generally, you need to work it once or twice. Okay, only then you will get it across the concept over here. Concepts are not very complex, but the only thing is you should know how to use it. Okay, thank you friends for watching this video. Do like, share, and subscribe to my channel for more updates. Thank you.